All right, here we go. It says Yolanda has 6 notebooks. There are 140 pages in each notebook. How many pages does Yolanda have in all? So, it says Yolanda has 6 notebooks. There are 140 pages in each. 1 multiply, divide, notebook. How many pages does Yolanda have in all? She has 6 notebooks. So we say Yolanda has 6 notebooks. There are 140 pages in 1 notebook. So how do I figure out how many pages she has in all? You multiply 140 times 6. 6 times 0 is 0. 6 times 4 is 24. Put down my 4. Regroup my 2. 6 times 1 is plus 2 is 8. All right, number 2, it says, which will solve the product of 128 times 6? Remember, this is just the distributive property. Remember when we did the quotations? Remember when we did this and we broke our number apart? This is saying the exact same thing without the quotations. So what number are we breaking apart? 128. We're breaking it up into being what? 120 and 8. 100 plus 20 plus 8. So I'm going to put 120 and 8.
Times 6.
And then it's going to be, each one of them is going to be times 6. Times 6. Times 6. So which one do we know it automatically is not? D for sure.
A for sure. And B.
And A, why do you say A?
Because it had for one cinnamon.
I don't know if I have any more cinnamon. Hold on. I think I'm out of cinnamon. I think I ate it all. She said one bubble gum for one cinnamon. Word. I think we're out of mint though. Hold on. Let's see if she wants a mint. Ask her if she would like one mint, because I do not have cinnamon. So take this and ask her if she wants one mint.
What in the world?
We're bartering. We're bartering.
You're just trading.
Bartering and trading are the same thing. All right, so we know, why do we know it's not A as well?
Because it has 8.
Because what?
Because
We know it's not A because 100 times 8 would be 800. 20 times 8 would be 160. 8 times 6 is 48. But when you add this up, that would be 128, but these would have to be the same. It can't be times 8 because it is times 6 over here.
with B as well, just like B. B has a 2 in it.
B has a 2 in it. So again, cannot be that. So the only choice it could be, what? Did she agree to the barter?
She already took one.
I knew she would. Oh, gladly. There you go. Put that green one on my desk.
That's the funniest thing I've ever seen teachers do.
Teachers barter for bubblegum. Because that's what we do. We live our lives in bubblegum. So, could have done it this way. But this is the exact same thing. 100 times 6, 20 times 6, 8 times 6. Right there. You didn't have to work this problem out. You just had to look at the structure of it. Number 3. Mabel packed 12 cases of batteries. There were 15 batteries in each case. How many batteries did Mabel pack? Mabel packed 12 cases of batteries. There were 15 batteries in one case. Multiply, divide. How many batteries did Mabel pack? So if we know she packed 12 cases, and there's 15 in each case, what do I need to do?
Multiply.
All right, so Mabel packed 12 cases. Whew, this has a kick or something to it. I can't decide. 12 cases. There are 15 batteries in one case. One case has 15 batteries. Bart. So how do we figure out how many is in 12 cases? You multiply 15 times 12. So, use lattice here. Lattice. Lattice. It's just easy. You just need to learn the steps. It's 12 times 15, so we're going to put 12 up top, 15 on the side. Shh, are y'all with me or not? Gabby? You and Christopher, shh. Put your mask on properly, please. So, everybody should have this paper out, looking at it and seeing what you did wrong. You do 1 times 1 is 1. So I put the 0 right here and the 1 right here. 1 times 2 is 2. So I put the 0 here and the 2 here. 5 times 1 is 5. Put the 0 here, put the 5 here. Why am I putting the 0 here? Because it equals 5, and the 5 would be in the 1's place, and the 0's in the 10's place. We just have to have it there. And then 5 times 2 is 10. So I put the 1 in the 10's place, and the 0 in the 1's place. So then I'm just going to add 0 plus 0, 0. 2 plus 1 is 3. 3 plus 5 is 8. 0 plus 1 plus 0 is 1. So my answer, 180 batteries.
That's 1,800.
No, it's not.
Oh. So the other 0
No, that one right here. That one's here, here, here.
Yeah, I get it.
All right, looking at number 4. It says Jack buys boxes of potatoes at the market. There are 30 potatoes in each box. How many potatoes does Jack buy? So if you know that somebody's got something and it's saying there's this many in that amount and whatever, you automatically should know that you're going to multiply. Automatically. If it says something like there's equal amount in each box, how many boxes would it take? Then that would be division. So Jack buys 5 boxes of potatoes at the market. There are 30 potatoes in one box. In one box. So how many potatoes does Jack buy? So we know Jack buys how many boxes? 5 boxes. How many's in one box?
30.
There's 30 potatoes in one box. In one box. My question is asking me the number of potatoes. So, how do I figure it out? I know how many's in one box, so I have to figure out how many's in 5 boxes. So, what do I do to figure out how many's in 5 boxes? I multiply 30 times 5. 5 times 0 is 0. 5 times 3 is 15. 150. Number 5. An elementary school collects drinks for a festival. There are 48 drinks placed in each cooler. There are 12 coolers. Which is the total number of drinks the school collected? There's a couple keywords in here that we can see. We've got total number
We have each.
of drinks collected. We have each cooler, and we have the amount of coolers that they have. An elementary school collects drinks for a festival. That's just extra information. We don't really need that.
In elementary school.
There are 48 drinks placed in each one cooler. There are 12 coolers total. Which is the total number of drinks the school collected? So we know there are 12 coolers. There are 48 drinks in one cooler. Question is asking me number of drinks in all coolers. So how do I figure out the number of drinks in all coolers?
You multiply.
You multiply. All right, let me make my lattice box.
48 times 12.
You do 48 times 12. Why am I doing 48 times 12, Gabby?
Because there are 48 drinks in one cooler, and you want to find out all of them.
How many's in all 12 of them? So if I have 12 coolers, if I have 12 pieces of candy on each desk, I need to figure out how many pieces of candy I have on all the desks. So I'm going to put 1 and 2, and then I'm going to put 4 and 8. And I'm going to say 1 times 4 is
4.
4, so I'm going to put 0 and 4. And then I'm going to say 4 times 2 is
6. No, 8.
4 times 2 is 8. Put my 0 and my 8. 8 times 1 is
8.
8. So put 0 and 8. And 8 times 2 is 16. Now I can add down. So 6 plus 0 is 6. That would be my first one. My second one. 8 plus 1 is 9 plus 8 is 17. So I put my 7 down and I regroup my 1. So 1 plus 0 is 1. 1 plus 4 is 5. 5 plus 0 is 5. And then we have 0 plus 0 would be 0. So the answer is 576. This lattice becoming a little bit simpler. Now, area model right here. Do I actually have to solve this problem? No. I saw a lot of you trying to solve this problem. It says an area model is shown here. Which multiplication expression matches the area model? Which expression? When it says expression, it means what?
Equation.
Equation. Matches the area model. So, what you need, Jayana? What you need? You had your hand raised, so I didn't know if you needed something. Okay, my bad. My sorries. So, now, remember when we do area model, it's blank plus blank and blank plus blank. So you need to figure out what is matching going down this way, what's matching going down this way. So like if I had my colors, what would be the same going this way, what would be the same going this way? So what two numbers do we have in common in these two boxes? 30. Are they going up and down or side to side? Up and down. So that means 30 is going to be right here. This is the easiest problem, and there was probably only 6 of you that got it correct. What two numbers are matching here? 9 and 9. Is it up and down or side to side? Up and down. So I'm going to put my 9 on top. What two numbers are matching this way? 20. So I'm going to put it over here. What two numbers are matching this way? 7. So I'm going to put it over here. So if I do 30 plus 9, it gives me what? 39. 20 plus 7 is?
27.
So 27. 39 times 27 is my problem. A bajillion of you put 37 times 79. Yes, ma'am.
I put in that answer because I thought you can't like multiply the same number and
Yeah, you can. So the only choice that it can be is A. 39 times 27. And we got all that just from looking at what they gave us. There was one like this on the NC check-in, but they gave you a blank, exactly this question.
But at that time I didn't understand it.
Okay, well, I hope we understand it now. If not,
Yeah, now I'm understanding it too.
there's only like 2 questions that were the same from one of the worksheets that y'all did.
I did this before because I got sick on Monday and Tuesday. I was on the log on Thursday and Friday. I meant Monday and Tuesday, and no, I don't know what I'm talking about. I forget what day.
I really don't know what to talk about
Because
it.
remember those 2 days I didn't go to school?
Yeah.
I had a rash, and then I was on the live, and then
Right,
y'all did.
because you're highly allergic to something. Yes. No, don't worry about it. All right, here we go. A principal is purchasing 7 pencils for each student in a school. There are 575 students. Which equation could be used to find how many pencils the principal is purchasing altogether? Pencils the principal is purchasing altogether. That's alliteration. That's a lot of alliteration right there. All right, so a principal is purchasing 7 pencils for each student. So one student gets 7 pencils. There are 575 pencils. Which equation could be used to find how many pencils the principal is purchasing altogether? So we can do a couple things here. We can go ahead and break it apart, 575, because when it's saying what equation, that's using the distributive property. So that means that my parentheses. But they kind of have it all written a little differently, so they're trying to throw you off. So if you just want to sit here and say, all right, well, they're saying you could answer all these problems and you would get the answer for 575 times 7 if you figured out that answer. Jody, can you please leave that alone and be looking at this paper so you can know what you did wrong? I'm not going over this for my own good. I'm going over it for yours. Or you can say, okay, well, if I look at these problems, it's saying 5 times 7 times 7 times 7 times 7 times 5. But when we break this problem down, it would be 500 times 7 plus 70 times 7 plus 5 times 7.
I really didn't pay attention.
Well, I need y'all to start. So we can only see 2 choices that could be it. So A and B are out. A and B, because they're not going into the 500. They're not 500. Okay. C is out. Why? Because if I make this into parentheses, they're multiplying each thing, but we're not multiplying. When we get a partial product, what do we do to them? We add them. So this is the same thing as saying, so the answer is D. All right, a store sold 400 ice cream cups during the summer vacation. An equal number of ice cream cups were sold during each of the 8 weeks of summer vacation. How many ice cream cups did the store sell each week? It says a store sold 400 ice cream cups during the summer vacation in all. An equal number, So if you see that equal number, what does that mean?
Division.
Division, right there. When you see equal number, you automatically think division. An equal number of ice cream cups were sold during each means what?
Multiply and divide.
Of what?
One.
Means 1, multiply, divide, of the 8 weeks of the summer vacation. How many ice cream cups did this store sell each week during 1 week? So of the 8 weeks, they sold the same amount of number. So what do I need to do?
Divide.
Divide. When you see equal number, divide. So you're going to do 400 divided by 8. So, can 8 go into 4?
No.
4 go into 8? No. So, 8 into 40. So, 8, 16, 27.
No.
No. 8, 16,
3 is 24.
24. My brain isn't working. 32. 40. 48. All right, we'll stop right there because we know we're not going to need to pass that. So, 8 goes into 40 how many times without going over?
5.
1, 2, 3, 4, 5 times. 8 times 5 is 40. Then I'm going to subtract. 40 minus 40 is 0. Then I have to bring down this 0. So 8 goes into 0 how many times? 0 times. So 8 times 0 is 0. Then subtract gets me 0. So if there's nothing else to bring down and this is less than that, then that means this is my answer. So how many ice cream cups did they sell each week? 50 ice cream cups. Turn it over. Number 9. Says there are 1,392 people at a basketball game. There is an equal number of people in each of the 6 sections. How many people are in each section? So we got a big number and we got a small number and we got the word equal. So there are 1,392 people in a basketball game. There is an equal number, that means to divide, of people in each one of the 6 sections. How many people are in each one, multiply, divide, section? So I need to do 1,392 divided by 6. Because we can pull that information out. We know there are 1,392 people at a basketball game, b-ball game. There are 6 sections, and if the question is asking me number of people in one section. So I pulled that information out. So now we can divide. Let's do our 6 facts. Ready, go.
6, 12, 8, 22,
6, 12, 18,
24,
24,
30,
30,
36,
36, 42, 48, 54, 60. I'm going to stop right there. So I'm going to say 1 divided by 6. Can't do it. I've got to make it 13. 13 divided by 6, number closest to 6 without going over, is 12, which would be 2 times 1, 2. So then we would multiply 6 times 2 is 12. 3 minus 2 is 1. Everybody needs to be looking up here. I'm not doing this for my own good. I know how to do all this stuff. I'm not the one taking the EOG. So then I bring down my 9. 6 goes into 19. How many times?
2.
Not 2.
3.
3 times. 3 times. 6 times 3 is
18.
18. 19 minus 18 is
1.
1. Bring down my 2. 6 goes into 12. How many times?
2.
2 times. 6 times 2 is
12.
12. Subtract gives me 0. So there are 232 people in one section. You could have honestly taken all of these answers. Shh. You could have taken each one of these answers and multiplied it by 6 to see which one would give you 1,392. Is that what you did? And that worked. And you got it correct, didn't you?
Yeah, I got it right.
Great. All right. Number 10. 144 students went on a field trip. Each seat on the bus sat 3 students. How many seats were needed for the students? There were 144 students on a field trip. Each means 1 seat sat how many students? 3 students. How many seats were needed for the students? So we know there are how many students? There are 144 students. We know that there are how many students fit on 1 seat? 3 students on 1 seat equals 3 students. So my question is asking me number of what? Number of seats that were needed. Number of seats. So how do I figure out number of seats if I know the amount of students and I know how many sits on each seat? Divide. So, what is it? 144 divided by 3. Do our 3's facts. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. So I divide. 14 divided by 3 gives me 4. 1, 2, 3, 4. 3 times 4 is 12. 4 minus 2 is 2. Bring down my 4. 3 goes into 24. How many times? 1, 2, 3, 4, 5, 6, 7, 8 times. 3 times 8 is 24. So that means there's 0 extra people. So how many seats are needed? 48 seats. Now, if there were 145 students, they would actually need 49 seats. But oh man, what?
Does the principal see this?
Does the principal what?
See this.
Say that one more again.
Does the principal see this?
Well, she sees your final grades and stuff, and if she comes in, she might. You never know. Yes, sir.
I know I did wrong one here because I was going so fast. I got the answer right, but I was
At
going so fast. I put 40.
10:40, Jaden.
I thought you said 40.
Yes, Sebastian.
I think I got it wrong because I didn't put the 4.
Right.
Yeah.
Now, these last 1, 2, 3, 4, 5 were all ones from that worksheet that y'all did. They're the exact same question.
What worksheet?
The division worksheet that was on Teacher Made.
Oh, that.
Yeah, all right. So there are 832 flags in a warehouse. The flags were placed equally into 4 boxes. How many flags were placed in each box? Each box equally, we need to divide. All right, let's look at number 12. It says Johnny planted 60 apple trees. He planted the trees equally in 6 rows. How many apple trees did Johnny plant in each row? Divide. 60 divided by 6. 6 times what gives me 60? 10. All right. Let's see. We've already done that one. And we've already done that one. So we're going to stop right there. All right. So I am going to have you, I'm going to come around and pick up those papers. Go ahead. So, no, it's fine. So they can go home. Great. All right. You never know. I may throw in some multiplication and division problems into your next test to see if you know it or not. Yes, Gabriel. Huh? What? Kamani did. She only missed one problem. What? That has nothing to do with somebody's intellectual ability. So, yep, I'm coming around. Pick them up. Jody, where's paper? Oh, that's okay. That's okay. What do you need, buddy? How do you know what you did wrong if you don't look at your paper? From where you started, you're doing fine. Where you started, you're doing fine. You're still showing right. All right. All right, you're going to need a, hold on, let me look. Let me look. Where's my math book? All right, you need to get a piece of paper out, please. It's not, bro. Go ahead, Sean. Get a piece of paper out. I mean, Christopher, don't
got to talk. Can you do it for the whole hallway don't hear you? Alright, illustrate me greatly appreciated. Guys, there are other people around us. And you don't need to be that loud. And I don't mean to be hateful or harsh, but you need to learn to use inside voices. Y'all are supposed to be setting examples for the little ones. Yeah, you are. Smart, Bridget.
Now, when it comes to equivalent fractions, we started talking about them a little bit already this past week. I can't remember if you guys were the ones that were here or not. Equivalent fractions just means that they are equal. We've done a lot of it in our morning work. Jody, I need you to put that up and get a piece of paper out, please, and put your mask on properly. So, just a little refresher. We can take a fraction and figure out if it is equivalent. If my fraction is 1/2 and I want to figure out a fraction that is equivalent to it. Yes, Alex? Yes, please. If I want to figure out a fraction that's equivalent to it, I can either, or find a fraction that's equivalent to it, I can just multiply by 2, multiply by 3, multiply by 4. So, if they give me the fraction like 3/6, I can say, is that equivalent by saying, okay, what times 1 gives me 3?
Are we doing this?
No, you're just watching at this moment. What times 1 gives me 3? 3, so they did times 3. So whatever they do to the top, I have to do to the bottom. So times 3. So is 2 times 3 equals 6? Yes, so 3/6 is an equivalent fraction. Another way you can find equivalent fractions is on a number line. When you're looking at a number line and you're talking about fractions, you're talking about a part of a whole. If we're looking at a ruler, we did this kind of at the beginning of the year. If we're looking at a ruler, we're looking at how many dashes are in between the 1 and the 2, or the 0 and the 1, because this is 1 and 1/8, 1 and 2/8, 1 and 3/8, 1 and 4/8, 1 and 5/8. So when we're looking at a number line, it just depends on what our fraction is. If it says I've seen questions like which point on the number line would equal 1/8. So you would have to know that if it's 8, if the number line is 8, then that means there's going to be 8 different sections. So just like if they did a tape diagram or a block, it's the same in a number line. So the number line's always going to start with 0, and it's always going to start with a whole, which in our case is 8/8. Because 8/8 equals a whole. This is 0/8, which equals 0. So half of 8 would be what? Half of 8 is what? 4. So this is 4/8. So halfway in between 0/8 and 8/8 is 4/8. And then I would have to split this one in 2 other pieces, because there needs to be 8 segments. So 1, 2, 3, 4, 5, excuse me, hold on. 1/8, I did that wrong. Please excuse my dear Aunt Sally.
Needs one more line.
Needs one more line on each side. So we're gonna break that one in half, or break 4 in half would be 2. So that would be 2. Let me just redraw it. I'm getting myself confused. So my two ends would be 0 and 1 whole. This one means 0 eighths. This one means 8 eighths. Okay? Half of it would be what? 4 eighths. Then half of the 4 eighths would be what? 2 eighths. And then half of the 4 eighths between 4 and 8 is what? 6 eighths. So say my question asked which, and there was points like this would be A, this would be C, and this would be B. Okay? It would say which, and we'll put D on here too. Actually, we'll put D over here. The question may say which point on the number line equals 1/8. So you would have to look and see, okay, if it's 1/8, we know it's going to be in between 0 and 2. So that would be this. It would be B. So if it's broken up into fourths, my first one is 0, my last one is 1, because fractions are part of a whole. So that means how many fourths is a whole?
8.
How many fourths is a whole? How many fourths? 4 fourths equals 1 whole. How many fourths equals 0? 0 fourths.
If we were to do 5, what's half of 5?
2.5? 2.5?
So we put 2.5 on there?
It would be 2.5. But this really works with even numbers. Yes, sir. Quickly. It's okay. All right. So if I want to break this up into fourths, I know that I'm going to have 4 segments. So I'm going to just kind of eyeball my 4 segments. 1, 2. I'm going to have 5 segments. You're right. It's not very straight, but it'll work. Because is there a number that's, it would be 2 eighths, yes, but because this would be 1/4, 2/4. I hate drawing these things. These things stress me out. Let's try this again. Miss Piper's having a wonderful day with number lines. 0 and 1 whole. This is 4 fourths. This is why I use, I changed my number lines to be rectangles. So there needs to be 4 blocks in this rectangle. 1, 2, 3, 4. So 1, 2, 3, 4. See my 4 blocks? Really, there's 8, but you know. So that means this part is 1/4, 2/4, 3/4, and 4/4. See how it's easier to see a number line as in a box. If I wanted to go up here and change this one into a box, I would either just so then I know that how much of the number line is shaded. I could say 4 eighths, because 4 of the 8th is shaded, because you guys know fractions on figures like pies and on rectangles. Y'all learned that in 3rd grade. So on the pizza, yes. So if I said show me a fraction that is equivalent to, or equivalent to 4 eighths, well, how do I change 2/4 to be 4 eighths? You multiply it by 2. So if I break these things in half, that means there would be 8 boxes now, and that would mean that this would be the same. So, trying to use what they're giving me here. Hi. So anytime you see a number line, just change it into a tape diagram. It's called a tape diagram, but we'll just call it a rectangle. Now, say my number is, I'm so bad at this is not my first day, okay guys? But I appreciate your help. I'm sorry. We got what, like 10, 15 more minutes. Yes, go ahead. So I'm gonna put a fraction up on the thing. And I'm gonna put some points on this number line, and I'm gonna ask you a question. You tell me which point it would be, okay? So, let's see. See, that's a half. That makes it a fourth. That makes it an eighth. This makes it a 16th. 1, 2, 1 16, 2 16, 3 16, 4 16, 5 16, 6 16, 7 16, 8 16, 9 16, 10 16, 11 16, 12 16, 13 16, 14 16, 15 16, 16 16. So, what's half of 16? 8. So that'd be 1, 2, 3, 4, 5, 6, 7, 8. 8 16ths. Okay. Then I'm gonna put a dot here, make that A. Dot here, make that B. A dot here, make that C. And we'll put a dot here, make it D. So, yes. Just that one's mine. Just that one. That's the purple one. This one's mine. Okay. She's coming. She'll be back in a minute. Alright, so if I want to say which point equals to 1 whole, they're trying to learn. Put your mask on. Oh, hold on. So which point equals 1 whole? Which point equals 1 whole?
16. It's the last D.
Put that back in the blue folder. Put it in the blue folder. Blue folder. It's just another version of the same math book that you guys have. He just has misplaced it. So we said which one equals a whole? D, okay? Which point equals 5/16? 5/16. Well, what letter choice is that?
This one.
Put your mask on.
No.
What is the letter that's up above it? C. Not B. B is 8/16. I said which one is 1, 2, 3. 4/16 is C. Then if I count up, it's 8/16, 9/16, 10/16, 11/16, 12/16. All right, let me ask you this question. Which point is equivalent to 1/2? B. Okay? Which point is equivalent to 3/4? A. Which point is equivalent to 1/4?
C.
Yeah, a bunch of geniuses. Everybody pat yourself on the back. All right. Very good. Now, when comparing fractions, you can also do something called cross multiply. Actually, let's do least common. Let's do, yes. 1/4 equals 4/16. Now, when we're looking at, it's not time for lunch yet. It's still my math time, so I'm going to use up all the math time I got. Yes, sir. Sure. My door is revolving today, apparently. If I want to see if this is an equivalent fraction, I need to find my greatest common denominator. Okay? Okay. Are you done? Because I'm done waiting for you to stop talking. It's very distracting. Okay. Well, I appreciate you accidentally saying it out loud, but let's just try to. So, when I'm talking about greatest common denominator, that means the denominator that they have in common. The greatest number that they have in common. So, we're going to write down our multiples or our fourths or facts to see if they have a number in common. So if I write down my fourths facts, I can say 4, 8, 12, 16. What's the greatest common denominator? 16, because they have that in common. So what times 4 gives me 16?
4.
Times 4, so if I times the top by 4, it should give me 4/16. Now, don't have to do it that way. An easier way to do it, 1/4 equals 4/16. You have to see if these are equivalent. You can cross multiply. 16 times 1 is 16. 4 times 4 is 16. If they're the same, that means they are equivalent. You have compared fractions. Now, if I say 2/5 and 5/10, we have to see if we're comparing them, which one is greater. Then I'm going to sit here and cross multiply. Okay? So 10 times 2 is 20. 5 times 5 is 25. Which one is greater or bigger?
10 times 5.
No, which one is greater, the 20 or the 25?
25.
The 25. So that means 2/5 is greater than 5/10. Because as the number gets smaller, the pieces get bigger. And as if the number gets bigger, the pieces get smaller. If I did this on, well, let's do one that, yeah, yes, cross multiply. Let's say 6/8 and 4/12. So if I wanted to do the same thing, I would cross multiply. I would say 6 times 12 is what? 72. So I'm going to put 72 up here. 8 times 4 is 8 times 4. 32. So which one is greater? 72 or 32? 72 is greater. 72 is bigger than 32. So that means 6/8 is bigger than 4/12. So we have literally, I just taught you how to compare fractions.
Just like that.
Just like that. 2, 6,
Why did we
1
need paper?
third.
Wait, why do we need paper? Yeah, why do we need
Because I thought I had time for you guys to do some.
Maybe
Because you never know.
Let's take this
All right, 2/6, is it less than, greater than, or equal to 1/3?
Equal.
Equal because what?
6 times 1 equals 6. 2 times 3 equals 6.
Equals 6, so that means they are equal and equivalent. Put that in your book bag. So you cross multiply.
I want to call that a name like
Nope, it's just called cross multiply. You cross multiply to find which one is less than or greater. And it's the same thing when you are ordering them. But we'll talk about ordering fractions tomorrow.